Yes, so welcome to this afternoon session. I hope you've enjoyed your lunch and had some few minutes and an hour to refresh. And I'm happy and a great honor for our workshop to introduce our keynote speaker, Errol Koolmeister from H&M Group. So Errol, he's currently a head of AI Foundation at H&M Group, which is a Swedish clothing company that is having operations in over 70 countries and over 5,000 stores. That's what I could get from your pages. And prior to that, Errol was a lead data scientist in London-based Vodafone Group. And also he was a director of data science for Think Big Analytics at a Teradata company. And it is my belief that today Errol will be presenting scaling activities of AI at H&M, and he can elaborate more on that. Please do write your questions that we will discuss and Errol can answer towards the end of the presentation. Welcome, Errol.
Thank you so much. It's an honor being here in a conference which actually is representing one of my biggest passion here in life, so AI, and how you actually do that from an engineering perspective is one of the topics I've been working on the last few years. So I am super honored to be speaking about how we are democratizing AI at H&M Group and how we've been doing so the last few years. We say democratizing AI because we like to paraphrase what our founder, Erling Persson, once said, that he wanted to democratize fashion. And of course, as you all know, the story, starting in the pre-war era in the 40s in Sweden, providing cheap women's clothes to Sweden initially, and then the world. Very successfully, and H&M is today one of the largest retailers in the world. But those of you not being in Sweden might not know that the H&M Group has other brands as well. We have the COS brand, we have the Weekday, Monkey, H&M Home, Other Stories, Arket, and Found. And some of you that has a very sharp eye might see that it says the fountainhead here. And I'm going to go into that in a few minutes, but I want you to put that in your mind because the fountainhead is really what we talk about when we talk about scaling capabilities at H&M. So before we start talking about what we're doing today, we need to mention a little bit on what we have done in the past. H&M is not associated today, or in the past either, of being a high-tech company. And I think that's fair to say. H&M has been considered of being a traditional retailer, the brick and mortar type of stores where you find anywhere in the high streets. The business model of H&M was extremely successful for over 70 years, opening new stores in the high street across the world. There is a reason why we have approximately 5 in central New York, because there's many people flowing through there. And forecasting, as we used to do it in the past, was all about opening a new store, having 10% growth numbers. And I mean, H&M was publicly listed in the 70s. Investing in H&M then would be probably one of the best investments you can do, just looking back. But having just 10% growth every year. So if we bought too much, we just open a new store. And that basically was our growth plan. What we realized in around 2014, 2015 was that our stock levels were starting to pile up. We were starting to see this in the back of our stores as well, and it was becoming quite serious. We also started seeing our share price plummeting. So I'm not saying causation here, but I think there is something there at least. So back then in 2015, 2016, our CEO back then, Carl-Johan Persson, he's of course started looking at what do we need to do, starting to analyze the market with the different departments that he had. So he went to business development, and he of course had attended one of these conferences where somebody says AI is the solution, AI is the future. And he was curious, what are we doing with AI in H&M today? So he put that task upon business development. They went out into the organization and started analyzing what are we doing. And of course, in most traditional companies, ranging all the way from banking to insurance to retail to telco, they had a traditional way of doing analytics. They probably had a SaaS installation somewhere. They were focusing on CRM. They were doing some type of activities based on data, but not too much. It was seen as a separate activity, and they weren't really extracting enough value. At the same time, they started seeing the digital natives coming running way past them, much faster, acting on these signals that were found in data. So Carl Johan at that time, he then realized we need to do something. So he went with business development and they formulated a plan. We need to do something with AI. That was the purpose. They initially went with an external consultancy firm to identify the high value, high feasibility type of use cases that existed in the organization. Those use cases in 2016 were very successful. So they picked some of them, like markdown online. You can see that on the screen here. They picked some personalization use cases, quantification use cases, and allocation use cases to the entire store. Quite high level and quite simple if you're picking just the most simple algorithms. And they had a saying back then that was, we need to focus on the value. We need to get a short payback period of this type of investment, and we shouldn't integrate it from the start. So these use cases, they were not best in class when it came to technology. They were not best in class when it came to algorithm, but they were best in class when it came to time to value. So they were extremely successful, and the payback period on some of these large-scale investments was less than a year. Less than a year of these type of investments is a relatively good thing. And I've done a few of them. And I know traditionally when you are changing infrastructure, when you're focusing on data, when you want to become more analytical as a company, you usually formulate a 3 to 5 year plan. And most of these companies, they don't expect to see any value after those periods. We've seen it over and over again. And we also seen these type of investments fail over and over again. So I think this was a very good approach, just to identify and act on value, not just from a PowerPoint perspective, not just from a hypothetical or theoretical perspective, but actually tangible, money in the account type of perspective. So it was so successful. So in the next few years, we started 1 or 2 more. It wasn't that many, but it was so successful. So now that we actually launched a new organization, H&M asked us, that the central team that has been setting all of these things up, that we want all core operational decisions in H&M to be amplified by AI by 2025. And imagine if we've done 10 to 15 large-scale use cases today providing significant amount of value. These numbers now are in the hundreds. So we, of course, realize that it is not feasible with the setup that we are discussing. And then the question is, why is it not feasible? Well, there are a few reasons for that, of course. One of them is that when we started these type of activities, from a technical point of view, we set up autonomous product teams. And of course, there are many ways of working with technology, but I think what has been modern the last few years at least is these 2 type of pizza teams. When you're having a team of software engineers, product owners, data analysts, and what have not, UX designers, and you go out and you want to deliver value fast. That first approach was really good for the first efforts. So when we launched, for instance, fashion forecasting, which is one of these use cases on the upper left side, they had a very good architecture isolated from that specific one. And then we had assortment quantification, which is the one in the middle here. It had a completely different architecture and different technical choices that they wanted to have. This, of course, were good for them. But from a larger perspective, it was very hard for us to overview these activities. It was very hard for us to streamline the technology choices, even though the processes of building a model and deploying it is relatively similar. And we saw this pattern over and over again when we set up these teams. It goes fast, but they tend to run into problem when we're scaling and integrating them into the business organization. It creates a lot of technical depth for these use cases. And of course, what we had in the middle here is the HAL platform, which is H&M Advanced Analytics Landscape. Primarily, that was the data lake, which we offloaded from our data warehouse to make data available. We wanted to have data and compute separately, so these product teams didn't need to think about capacity, for instance, which was the the way of the past when we had on-prem Hadoop platforms having compute and storage together. So that was one of the first problems that we encountered. But we then sat down and we started trying to understand in even more technical depth, and of course conceptual depth and other types of depth, what were the main problems that we were seeing as an organization when we were trying to scale these software engineering projects. First of all, resource constraints. And I'm not talking about resources when it comes to money, because H&M has been very good at, if there is money on the table, they're willing to invest. If we can prove a positive return on investment, they're going to give us the funding. But on the other hand, there were two large resource constraints when it came to people and skills. It is quite hard to hire machine learning engineers, data scientists, skilled software engineers, DevOps specialists, cloud specialists, etc. We can't find enough of these people in order to fulfill the demands that we have on the organization. There was a lot of waste and deduplication. As you saw, these product teams, they were set up independently to be very autonomous without too much of a guidelines in the beginning, which then rendered, of course, people were inventing the same thing over and over again. We also realized that there was a long development time in all of these type of efforts. And long development time, of course, meant that they were doing it for the first time. And when you're learning to ride a bike, because that's the analogy I came up with, it takes longer, rather when you're building on experience in these type of development processes. And then, of course, in general in H&M, when we try to integrate these things, even though we were able to hire 100 approximately engineers to fulfill this for us, we had a problem because on the other side, there were people with project management background. So when we needed to speak to an engineer for integration purposes, we were met with a lack of understanding of what we were trying to do. In addition to that, the inefficiency in the processes of new use cases, setting them up, discovery, and proof of concepts was very inefficient because we didn't have that in the back. And in addition, slow time to market, which basically means we have built something, now we're going to roll it out. Rolling things out takes longer time than actually building them. So if we exist in over 70 markets with 177,000 employees, there's a lot of change management to get people to actually start using the technology. If you thought it was hard with traditional software, imagine doing it from AI. Getting buyers to trust numbers is very hard because they believe they know best. So change management actually goes into how do I make people trust the results of the models that we are building? And that wasn't the easiest thing. It's actually where we spend the most of the time. Lack of best practices. When you're building these capabilities up, there's no library of best practices. The only thing we can rely to then is experience and research outside of the company. We didn't have a documentation of processes, what works for us, etc. And then in general, goes a little bit into the lack of engineering knowledge, but it was very low data and AI literacy across the organization, which meant it was very hard for us to actually discuss these topics with anyone because they saw AI and data as black boxes. They saw data primarily as dashboards, and AI they saw as something they had no idea how to actually handle. That was something they did in universities and schools, but hey, we work with economy here. So we also realized, and I'm realizing I'm stating a lot of our problem statements here, but they're important to understand to start being able to deep dive into the solution that we later on propose as well. So we also realized that these two pizza teams, as people tend to call them, was very successful in the beginning. But as I just showed you as well, is that we had a lack of resources in general. And the math is really simple here. If you have a team of 8 to 12 people delivering one use case, how many people do you need if you have hundreds of these teams? The problem here is not that we can't do it. The problem here is there isn't enough people on the market to be able to deliver on the set targets that we actually have. So having that math in mind, we needed thousands of people in data science, in software engineering, in machine learning engineering, skilled product owners, if we wanted to reach our goals by amplifying all core operational processes in H&M with AI by 2025. So we needed a way to work smarter, not just harder. Smarter, not just harder. And what does that mean? Well, the first thing we started doing was how do we shift the discussion from use cases, because that's what companies tend to talk about. If you go out into the market, everybody's talking about use cases. You need to do more of these type of use cases, or you need to do these use cases. What's your use cases backlog? That's not what we wanted to do. We wanted to shift the conversation into talking about what capabilities do we need to build in order for us to do use cases. So start with the capability building now, and then focus on the use cases. For us, of course, that meant we need to build on a solid data enablement part for the organization, because without having a stable data platform, we would not be able to scale. That, of course, means master data management, GDPR compliance, data cataloging, lineage, anonymization, batch processing of these type of activities, stream processing, event processing, cleansing, normalization, aggregation, different type of databases to store the data, time series, caching, archiving, connectors, etc. Having that in place, we can then start talking about the AI capabilities, because this is a process. AI and AI engineering and machine learning engineering, MLOps, follows relatively clear set of process guidelines from start to beginning. It's everything from how do you develop model? What capabilities do you need? How do you give people access to the data? Is it through notebooks? How is that set up? How do you make it fast and efficient to receive that type of access? How do you then go from model into productionization and deployment? How does those pipeline look like? What capabilities, reusable components do we need to have in place to take that development time down? The lifecycle management, how do we make sure that when we develop things and they're in production, how do we detect data drift, model drift, and all those type of concepts? How do we have an easily incubation type of setup with proof of concepts and development support? How do we have PLM and industrialization? How do we have a control tower? So when things are deteriorating, we actually have a clear view on our different use cases in production. How do we have document and cookbook capabilities, visualization capabilities, data abstraction layers type of capabilities? How do we have a reusable output, AI literacy type of capabilities, infrastructure as a code, and common standards? All of these capabilities, so we can easily incubate new use cases, because here is where we start firstly to talk about use cases and incubation, and create the same capability for multiple processes and same output for multiple analysis, so that our users, the product teams in our organization, the business and the tech users, the end users and consumers, can deliver significant amount of value in a faster time period with less type of resources. So our way of doing that was to create the concept of the fountainhead, which is the encapsulation of our AI capabilities. Other companies might talk about the platform, but that's not what we're talking about. We're talking about an encapsulation of capabilities. So when we talk about the fountainhead in H&M, then we understand, okay, it's the AI capabilities. What do they exist of? And this is what they exist of. So the vision then of the fountainhead was really about unlocking of value, to democratize it across the H&M group and reduce the time to value in a sustainable and ethical way. So what we wanted to do is to build central, scalable AI capabilities. Not central use cases, but capabilities. So that the team that we were talking about in the past, with the engineers, the analysts, the product owners, the software developers, the data scientists, etc., they could start with these capabilities. So they had a starting point. They didn't need to start with everything from scratch. So that the domains in H&M, from called customer fulfillment, sourcing and production, tech enablement, customer assortment and production development, colleagues and corporate support, could set their own use case guidelines, but they could use our capabilities. So we staff their project, we give them the capabilities, and they'll reach value much faster, which is what it's all about for us. So we talk then about capabilities, but we also talk about reusable capabilities. An example here is with reusable capabilities, multiple processes in the organization can be amplified much faster than before. So time to value is of the essence for us. So what we're doing now is going from vertical capabilities that were one-to-one core processes, amplified by developing things from scratch. An example here is what we did in one of our use cases called Movebox, where we started with demand forecasting. We had a return predictor, optimization, and then output. Instead, we're going to turn that into a horizontal capability, which is what we have done, where we have demand forecasting, return prediction, and the output being reused. So these capabilities can be AI models, data, pipelines, infrastructure, data output, or competences. So when a new team comes in and say, I want to have a demand forecasting capability, or I'm going to build it myself, they have the possibilities to use these as the Lego bricks, which is, of course, what we've been talking about for many, many years. But in AI and data, it feels relatively new and fresh because we haven't really explored those concepts yet. But obviously, these are built on existing notions on how to speed up development and make time to value much shorter. So how do we successfully leverage these type of reusable capabilities? One, of course, is identifying the right type of reusability. It's the process of making the capability available in most suitable way. We create blueprints for how to build reusable components to facilitate for users. We make the capabilities available in a transparent way. So it's all about communication, making sure people actually know where to access these topics to ensure that they are discovered and fully leveraged across the organization. What we realized, the hardest part is not creating the capabilities, but it's actually getting people to start using them. Just as if you don't know there's a piece of software in the market that can solve your problems, the same thing goes. If there are capabilities in the organization that can solve your problems, you're not going to use it unless you actually know about it and know how to use it. And then we need a proper governance structure to ensure ownership and a process for maintaining these capabilities to ensure reusability over time. It's just like any open source project. It's not enough to have one or two people working on it, but you need a community to help it grow and help it be integrated into your software stack as well. So that's what we're working quite heavily on right now. We have several of these already being set up and being used. Some of the learnings we've done so far is our first use case starting from scratch took 12 months. The second one, with reusable components in the first go, we reduced development time down to 6 months. Now we're down at approximately 3 to 4 months, and we wish to push it even further to actually have a shorter time to value all the time. What we do is also that we push for build for reusability. So when we talk about these topics, we talk about service reusabilities, where we have API layers to connect service to, virtual machine and data platform to host service on. We talk about code reusability. So we have general code access to Git. So we are opening up all our different repositories so people actually are able to use them. We have dedicated repositories for people to be able to reuse. We have a clear release and maintenance according to semantic versioning standard. High quality code written for general use. That was usually the biggest problem. The code base written by data scientists was usually so bad, and it was so spaghetti type of code that we could never reuse it. Now we have actually enforced quite high coding standards as well to make sure that people write code that is reusable and scalable. And then when it comes to data reusability, it's a general access to a common database. That's an oversimplification, but the idea here is to have general access type of setups, consistent data format across the AI development, and data generated on necessary granularities, depending on what you want to be able to reuse. So building for reusability. What we also want to do here is democratizing AI in another sense. One thing is doing it for the people with the technical know-how, how to actually implement different type of algorithms and build these type of systems. From our perspective, and what makes sense for us, is to give people what they need along the whole development and deployment journey. We talk about amplifying all core operation processes with AI. We need to give different users what they need to be as productive as possible. So it's not just on the engineering data science side where they can go in, they can import from scikit-learn, they can build neural networks from scratch, but it's rather from the kind of product owner, business expert, data analyst, which might not understand how to do these things, but they can interpret the results and tell if is it good or bad. And the idea of doing this is really democratizing AI to make sure that they have tooling rather than code. So they're different users, and we need to match their need with the capabilities that we're building as well. So it's a relatively large thing. And why do we need to do that? Because one of the things that we realized is that end-to-end suites, and this is really what we're talking about, these auto ML type of tools, is needed because we need to democratize AI through easy to use tools, so the no code, low code type of tooling as well, for citizen development, and increase productivity. Because remember, there's not enough people in the talent pool to deliver on these activities that we need to hire. We can't do it fast enough. We need to hire just 80 more people this year just to meet up with the demand. But if you look on then the value and use cases type of setup, not all of the use cases are high value type of use cases. Some of them are actually relatively low type of use cases. So setting a team with 8 to 10 people would be an overinvestment, and it would be a negative ROI. But if we want to enable all core operational processes, we need to work smarter and get a positive ROI as soon as possible. That's where end-to-end suite comes in. They might not yield the absolutely best results, or I would say the judge is still out on that, but they would yield very good results with very little effort, which means the return on investment would be much better compared to actually putting a full team of data science and ML engineers on that and then scaling it globally. So what we want to do is enable data analysts, product owners to have this type of citizen development as well. And the first initial testing we have done shows very promising results, and we're continuing to develop and invest in that area as well. The other part is investing more in data and AI literacy, and being really transparent on where H&M is. We sent out a survey to all of our 250 product owners, the people ultimately responsible for the technical development in the organization. The results were that 70% of the product owners were not mature enough to leverage AI by their own self-assessment. And there are probably a few in there that actually assess themselves as mature, but I would rate them as immature. The results as well were 50% of product owners mostly wanted help in ideating how AI can be used. So not even development, because that we can support in another type of setup, but they wanted help understanding what they needed to focus on in order to implement AI into their products. And one of those was really, they needed help in understanding. So it's the understanding part, how AI can help us. So even though I sit in an organization which is technically quite savvy compared to the rest of the organization, we could never roll all the things we wanted to do out because there weren't an acceptance and understanding of the organization or the things we wanted to build. So some of the activities we now have identified in order to increase the AI development in the organization is ideation support. Obviously, it goes one-to-one to the needs mapping, where we transform ideas into value-based AI use cases. We see a focus on supporting the core processes, dedicated trainings and support in early phases, and of course, access to tools, training, and best practices. So that's our plan in supporting the organization going forward. So I'm speaking quite a lot about the problem statement and some of the things we've seen. What we have done in order to address all of these things, and I'm going to deep dive into one of the technical conceptual setups as well shortly, is to launch a large-scale program to deliver the Fountainhead. And this is ongoing as we speak, and it's already delivering into production with all of these activities. What we see is that we need to accelerate value creation. So focusing on value still and continuing to scale this. Technology architecture, we need to up our game when it comes to AI engineering in general, because the field is moving so fast. So we need to pinpoint the conceptual architecture, map that to best practices, and just go out and build them. We need to enable H&M Group, which goes back to the upskilling of the organization, a clear from vision to actions, and then, of course, resources and requirements, which must be the hardest of all of these. So let's deep dive into the acceleration of value creation. Value creation is to have an immediate focus. Remember, what was successful for us in the past was not to launch a 3 to 5 year long project. It was to actually have incremental value delivery as we were going along. So for us, it was really focusing on how can we do this again, but working smarter on the problem. So we identified 2 horizontal capabilities that we wanted focusing on in the beginning, building on the vision of the Fountainhead. The first one was demand forecasting at scale. Rather than each controller making their own forecast, how can we get the organization to gather around? So for instance, how can we do in-season moves between warehouses? How can we do online forecasting, trail forecasting, store-to-store type of forecasting? How can we get replenishment and delivery optimization out into the organization? How could we make buying corrections and on-demand production? So that was kind of a focus for the supply chain and pricing. On the other hand, we had personalization on the customer side. So personalization at scale is not easy. Doing a simple recommendation algorithm, which most companies do today, is relatively simple with the tools and technologies that we have. But having 150 million members in your club card in diverse locations, you need intelligence to build intelligent systems. So what we wanted to do is see how can we build reusable personalization components, reducing the time to value starting in 2021, but already delivering value today. And then, of course, having simpler AI for everyone, going back to our end-to-end suites to democratize AI across the organization. The big part here, when we talk about focusing on value, is that in the past, we identified these activities and we picked value potential and time to value as the main components for prioritizing and sequencing activities. Now we added a third component, which is reusability, because that will throw the roadmap up in the air and we will get the value faster. So if we're doing in-season demand forecasting, we started with our use case Movebox, which is balancing of warehouses. That algorithm itself will enable 3 to 4 other use cases. So we'll reach the critical component of those systems, delivering value much, much faster than if we were doing them in a couple of years with an end-to-end capability. So we are already proving that right now that we're moving faster, we're generating more value, and we don't need as much resources when we're developing these activities. We work smarter, not just harder. So that was very shortly around the value creation. Let's talk a little bit more about the tech, which is, of course, a very interesting topic for me personally, and I hope it is for you as well. So if you remember one of the first pictures I showed you, where I showed you a lot of the architectures, of course, very high level, we realized very early that there was benefits of unifying the architecture. But how do you go out and you tell 10 different teams that they need to oblige to an architecture? Well, we didn't. What we did instead was that we launched something initially that we called just a reference architecture. These are the best practices built on the use cases we have, but also the scalability, experience, and research that we have found so far in the topics. If we can harmonize around one reference architecture, that means we can have less maintenance cost in general. And a good example here is that those decisions led us to go from HD Insight on Azure to Databricks. Even though Databricks were more expensive on the spot prices, we reduced reduce the total cost with 70%, just because we had on-demand compute and it fitted our processes much better. We also see that there was a lot more benefits in more convenient to develop and test models for a data scientist. They had one entry point and they could go in and they could really have a faster development cycle. It was easier to run and build individual models with a more modern architecture as well. So if we had the CI/CD best practices, if we have deployment pipelines, we could go to production much faster. And also, we designed it for developing common assets. So having a unified architecture meant that we could reuse the capability from a technical standpoint in different use cases. And also, of course, more secure access to data and development environments. So these were some of the main benefits that we saw. From a very simple perspective, we mapped out the computational patterns to start with. We went from the model development, which is usually a very intense type of setup when you're running multiple tests and you want to see what generates the best results, and then how you deploy things. So in the first just week or so, we just put this together to see what are the best practices based on what everybody's doing and what we know. We went different tools and technologies, and we said, hey, this is the process. Please start migrating towards it. So minimize your technical debt. And of course, that was very early on in the stages. We then took a little bit more thinking time, and we developed a target architecture from a conceptual point of view with key components for end-to-end supporting capabilities, and launched version 1.0 together with our different product teams, where we go from the left side, which is data enablement, into ingestion and data transformation, into model training and development, into model production and deployment, all the way out to output and inference and usage, where we see different tools and technologies supporting in different parts of this process. So for us, it wasn't really about having people use the technology just because we wanted to. What we wanted to do is talk more about the capabilities. How do we detangle the architecture that you're using today? How do we support you with different capabilities? And then, of course, where are we? So if this is our target architecture, and if we have a generalized picture, where do we start in architecting these capabilities? Because we can't do everything at once. These are many systems, and this will hit many users, hundreds of them. And it's not something we will be able to do overnight. So what we did initially was just to map how mature is H&M in all of these different processes. And of course, being very transparent there, going from low maturity and, for instance, in labeling, non-advanced data science platform, feature stores, experiment tracking, feature servers, output access and reusability, platform front ends, deployment versioning, to being relatively very mature in data flow automation, batch predictor, etc., gave us a starting point on what central capabilities do we need to build from a technical point of view. So it's just taking a stand on where are we and where do we want to go. So we then created, of course, a tech backlog with prioritized components for centralized development, where we saw here are some missing components and tools that we need for technology MVP. So feature store, feature server, deployment versioning. And here are some existing components and tools which we need to develop and have integration efforts needed for technology MVP. So data flow automation, we're good, but how do we increase centralization and uniformity? Experiment tracking. How do we have development integration framework to support end-to-end experimentation? Output accessibility. How do we make sure that we have better APIs, simple UIs, etc.? And then, of course, how do we have increased automation, common processes, improve and integrate? So there were a lot of things we need to put into the backlog a few months back to make sure that we're actually focusing on delivering value for the entire organization. And I know there's a lot of information coming all at once. I will be more than happy to share all of these slides with you. So either take just screenshots or just ping me on LinkedIn. I'll send you the slides as well. So just on a conceptual point of view, for supply chain and pricing, if that was our base layer to understand the computational process and tools and map those into central development, we also in our dialogue needed to have a conceptual architecture around which components do we need to build. And we, of course, identified in demand forecasting support, optimization, and other for sourcing and production, for instance, where we mapped out the different reusable components like in-season for store, pre-season, long-range sales model. How do we calculate elasticity curves? How do we have substitution models? How do we do returns predictor, trend model, concept prediction, etc.? And how do we do markdown optimization, allocation, concept optimization, etc.? How do we create these capabilities and how do we sequence them in our development cycles? So we did this both for supply chain and pricing. And on customer, of course, we started with the first model. So how do we do lifetime value models of our customers? How do we calculate profitability of these customers? How do we do promotions? How do we do product recommendations, collaborative filtering, trend boosting, outfitter recommendation? How do we do size modeling? How do we do marketing, etc.? And how do we make this available for everyone to be able to consume for the organization? And I'm jumping quickly because I think this actually is a much nicer, prettier picture to understand what it is that we're trying to accomplish. So, for instance, this is conceptually how this system would work, which we are currently developing. It's about 90% done with many of these components, is my estimate. So the engine components. How do we do different modeling from an AI perspective? So how do we do propensity modeling for label matching? How do we do product and style category match engine? How do we do image recognition engine? How do we do neighborhood models? How do we do customer-centric product segmentation? How do we do trend forecasting? How do we then make them available through offline batch, API, real-time scoring updates to go into a contextual intelligence layer? Remember, it's not just about the model and the output. It's about putting it into the right context as well. How do we calculate the state of a customer? How do we have the business rule like eligibility, anti-repetition, anti-conflict, sensitivity filters, etc. To make sure we have an orchestration on top of that. What is the correct strategy, message, how to react, reach the customer, when to reach the customer. Having that also in a text experimentation type of setup, A/B and multivariate testing, multi-arm bandit, reinforcement learning, etc., execution, microservice type of layer, measurement, capture, customer feature store, product feature store, etc. So all of these being working together as well. So that's the long-term capability stack that we're working on at the moment. And I would like to mention just a few things about abstraction layer before we're starting to wind down the presentation a little bit. A crucial part of machine learning is access to data. And what we're working heavily on right now is creating a data abstraction layer to minimize the dependencies towards the common data platform of H&amp, where we've gone from direct access of source data into a use case data table into a data abstraction layer, we could reach as a layer to minimize the dependencies towards the underlying data complexity. So for us, if you put that into the context of AI engineering and the process, a data abstraction layer is actually covering many of these topics like data flow, automation, feature stores, the different platforms, the model development, the tracking, etc. Not all of them, but many of them. So it lies as an abstraction layer itself to be able to serve the AI engineering use cases that we're doing. And an abstraction layer is a combination of different tools and technologies, and it's required to build a data abstraction layer. So how do we get streams in here for real-time access? How do we have access to the data lake that we have today? How do we make sure that there's a clear monitoring, transform, storage, and serving and registry of these things? How do we serve models on top of this abstraction layer? And how do we train models on top of this? And what tools and technologies can we use? And these are some examples only. Is it Kafka, Databricks, Tekton, Feast, Databricks, Hopsworks, MLflow, Seldon, etc. So it is a relatively important topic for us as well, which we're working quite heavily on. I just wanted to mention that really, really quickly. And then, of course, understanding the blueprint architecture, which is defined on the best-in-class capabilities and proven architectural patterns. So a final thing here on data is that the guiding principles and patterns that we're following now, building our data layer on top of this. And as I mentioned, this is a relatively busy slide. Just ping me and I'll send you the slides and you can go through them in peace and quiet. So let's talk about enablement of H&amp Group. Enablement is all about how long-term do we build these AI capabilities. What we realized so far that implementing AI at scale in organization is 10% about algorithms, 20% about technology, and 70% around capability building and processes. So for us, it's focusing much more on actually having people to understand what they use these things for, rather than just hoping that everything will be managed by a central team. For us, it is having a literacy agenda. And a literacy agenda is all about making sure to enable the rest of the organization. How do we help them with domain ideation of AI use cases? How do we train them in AI? How do we have different forums and communication channels? How do we have documentation and templates? And that's our best practices team. They have an exploration team where we do ideation, articulation, and support, exploration, proof of concepts, development support, and of course, a lot of learning and development activities around communications, online courses, use case examples, communications, communication materials in general, leadership training sessions, technology enablement team, all backed up by a large data literacy program as well. So it's not something we take easy on. It is actually the key enabler for us. If we want to continue building great technology, we've got to make sure people are actually using that technology. It doesn't matter how good technology we build if nobody uses it and the value is not realized in the organization. So going from vision to actions, I love sharing. So here you can see our latest roadmap. I hate doing roadmap, which is 5 years long. But unfortunately, they are needed to actually have funding for these type of activities. We've already now started scaling the existing use cases that we are running. We have started building demand forecasting at scale capabilities. We're now working with all of the different supply chain processes to actually amplify all core operational processes for them, mapped out all the use cases, and have started to build now. Amplified customer experience through hyper-personalization, which is personalization at scale. We have started building the platform for the first interactions with H&amp.com, 90% done approximately. We're launching the first use cases now. We have created an AI academy in the organization and are rolling all of these things out. We're doing the first training course next week already with the first 15 people to be trained. And then we're going to train the rest of the organization after summer. We are also doing proof of value, proof of concepts with end-to-end suites as we speak as well. Handling the talent acquisition type of setup is we're going to set up global hubs now. So we're already now investigating where in the world do we want to set up new hubs, looking at North America as the first deployment options, Toronto, potentially New York, Austin, etc. A lot of these places that we're going to start launching the new hubs in after summer as well. And then the final here on 6 different components for the main focus. So just summarizing, what we're doing here is platform and enabling teams for the organization, going from use case specific to talk about enabling capabilities. Use cases, we help the domains, and we're doing personalization at scale. We're doing demand forecasting at scale as the first go to amplify all core operational processes right now. Upskilling the entire organization. We are around 3,000 people today in central IT, central AI, central data type of teams. We're going to upskill all of them. Recruiting efforts, future capabilities, and domain support. And I think that takes us to almost 45 minutes of presentation. And that's the final slide. Thank you so much for listening in. I hope it wasn't too much. I know I crammed a lot of in there, but I think sharing is caring.
Thank you very, very, very much for this wonderful presentation. I think we have huge applause to you for this very detailed and a lot to chew in. And I will basically ask a few questions that I have, but we, as you can see in the chat, we actually have many, and I hope we are able to cover. So you have quite given a good and interesting presentation. So well done.
Thank you.
Yeah. So one question. I mean, overall, I think much of the themes that came up, we also discussed relating to understanding the need to understand what people can do with AI in respective companies, but also the need for expertise and what education should be taught in our institutions, like regarding this AI engineering. But I think one of the key topics that also emerged was relating to testing. And throughout your discussion, I was hoping to hear something related to that. So maybe one question from my end before I ask from the audiences is what kind of testing do you do, both from the infrastructure, but also from AI components themselves, because we do understand it presents a different perspective from traditional software.
No, but you're right. That's 2 different type of testings. So from a testing perspective, we try to have as good test coverage as possible. I mean, a traditional CI/CD type of testing, we try to have a test-driven development, but for some reason, it's very hard when there's data scientists involved to write tests before they actually start writing functions. So we have a clear target of having minimum 60% text coverage from a traditional point of view in the entire chain of testing. That's just from a traditional software engineering perspective, which we are enforcing and tracking and following up. The other part is testing of your models. And I have a saying, I don't care how good your model is unless it's actually tested in production. Because you can have very good testing in AI, data science type of perspective. You can have different types of tool that you can have cross-validation, etc. But unless you actually put it into production, then it's not valuable in my point of view. That's when you start realizing. So what we are aiming to do now from a testing perspective is being able to do canary deployments instead. So we can actually test semi in production before we upgrade the model. Of course, that's hard to do when you don't have anything in production, but most of our systems start to have that. So what we're trying to enforce more now is when you're testing your models and the performance of them, have them in canary deployment first. So we're working with companies like Seldon, for instance, which are very good on deployment when it comes to online, at least, to enable these type of deployments instead. Other than that, we follow traditional methodologies in testing models and how accurate they are before going into production. I hope that answered some of that question at least.
Yeah, we could dwell the whole day, but maybe we go to the audience questions. I'll start with Luis' question, that what are the main challenges in setting up the right process to manage ownership of ML projects?
It's a It's a very good thing. The right process and ownership in general. I mean, what we want to do is create these teams where there's relatively full autonomy in the team. I say relative because I've learned that you can't have full autonomy, because then will people run off in different directions and you have no control. But it's important to have somebody in that team to feel ownership over the development. So it's important to make sure that the product owners in the team you're setting up, they are responsible. And what we've realized is, if they are accountable for everything, they are also going to act like they're accountable for everything, which means that they will take ownership. I'm not sure if I'm answering that, because I have a hard time actually understanding it. There are different types of ownership in ML projects, in my point of view. One is the one you have on the business side. Those are the ones that are going to say, yeah, I'm going to commit money to actually build those things. And I'm going to be a stakeholder, and I'm going to track, and I'm going to follow, and I'm going to hold you accountable. The other part is the ownership of developing the ML model. Those are usually the use case lead or the project managers. And then, of course, you have the ownership in the team of developing, and that's usually the data scientists and the machine learning engineers and the software engineers. So the different levels of ownership, which makes it semi-hard to answer that one. What we've realized, the best way of doing it is just setting up these product teams, having clear OKRs, so objectives and key results, and then track that for following up. It's been very successful for us, at least.
Yeah. So Ivica is thanking you for a great talk, and he's questioning that your capability is centralized. Is it also centralized physically, or do you have centers in different places or countries? If yes, what is your experience in managing distributed organization?
Well, I worked in both type of organizations. Currently, we are only centralized because we started in Stockholm. It was the easiest to continue building in Stockholm. It is definitely not the best model long term. Currently, we have development center in both India, China, and New York. We are actively recruiting there. What I think, when you set up distributed organization, it is important that you have clear strategy on how these organizations are going to work. So one of the topics we are wrestling with right now is, okay, if we set up these hubs, do we set up independent product teams in these hubs so they work independently towards a business goal? Or do we have them as an integrated part in an existing team? So you have a follow the sun, you can have somebody in, I don't know, San Francisco, Stockholm, and then China. And you can have a follow the sun type of development where the team hands over. Or do you work just by resource augmentation? And the answer is always, as the consultants say, it depends. Because it depends on what purpose you have with setting the team up. What is a key for successful distributed organization is making sure everybody feel as a central part of the team. And that goes back to culture. How do you build a good corporate culture where people feel included and invited into the organization, rather than feeling they're just hands being outsourced a task? So that has been our key. If we integrate them more into our organization and welcome them better, then it works much better as well.
Yeah. So we also have a question from Filippo, who needs a bit of clarification. Do you rewrite data scientists' bad code or ask them to improve code?
Relatively sensitive. I'm hoping not too many data scientists are listening in, but both. In the beginning, we need to rewrite entire systems. We couldn't ask them to do that, but then we had to rewrite. Then we started enforcing that they had to commit the code into versioning control, and then they got feedback on the code base, which actually made them better coders as well. So if they had a senior software engineer that actually reviewed what they were writing, that made sure that they learned how to write better code. So in the beginning, much more rewriting when there was a lot of technical depth that we needed to parse through. But now we are actually upskilling them in how to write better code. The other part, which is not in this question, is that we minimized the amount of code they needed to write. So in the beginning, they wrote pretty much anything, because in the beginning, they just hired data scientists. Then we started hiring engineers, so the engineers could take over many of those tasks as well. And we moved the development into better UIs. So they didn't need to IDE type of setup where they wrote the code. Now they can use a notebook instead, which is centralized and version control, and then they have a better strategy of handing that over. So it's a clear cut between what's software engineering and what's data science and model development.
Yeah, interesting. Then we have another question from IPEC. How much of this architecture was developed with AI in mind versus modernizing legacy? What were the challenges with legacy and AI element?
So we had the opportunity when we started everything out to pick the development area, and we picked going fully cloud from day one, which meant we didn't have any technical legacy from our perspective. So we didn't have to modernize existing infrastructure to be able to build all of these things. And I think that was a key success factor. The first stumbling effort, which is offloading all the data from the central data warehouse to separate data from compute. And of course, the compute instances, they were set up as separate nodes. So each use case had full flexibility in setting up their own infrastructure to start with. So all of this was developed with AI in mind. Then if the people that actually set it up initially knew exactly what that meant, I'm not sure. But today it's not just set up with AI in mind, it's set up with AI software engineering best practices in mind.
Yes, so moving on, we have a question from Eustace, who found the talk very interesting, especially that you're planning to have 2 data science platforms, one for advanced users and one for non-experts. Do you already have any ideas how this platform for non-experts would look like? Will it focus on visual programming with drag and drop building blocks?
Exactly. So what we're aiming for the non-experts is the no-code, low-code type of tooling. So I mean, you probably know most of them. It's like the data IQs, the data robot, H2O.ai type of systems. Personally, I like the more advanced systems where you have more access, but that's because I've been working with it for a long time. If it's non-experts that's going to use the platform, they need more guidance and tooling and support. So these are the type of tools that we're looking at.
Yeah, so a question maybe from my end. I think it was a bit provoking in the beginning when you say like you shift the discussion to AI capability rather than the use cases. But in often when we read or we go to companies, you have this experimental part quite extensively where you try to show proof of concept with AI and a model and a use case that is attached to it, so that you get resourcing for AI capabilities and the technical work around that. But you had this mindset of shifting it where you start with AI capabilities. But in a company that has limited resources, and as maybe also yours, you said the resourcing is a bit constrained. How do you balance this, like experimental one and also still focusing on AI capabilities?
Yeah, I think AI capabilities come a little bit down the line. I think experimentation and use cases usually come very early on. And yes, it's supposed to be provocative as well, but I want to change the conversation. And then you need to be a little bit provocative. But I think for these companies that don't have much efforts or much scale, they still need to have a clear strategy on what they want to achieve with AI. And usually when I talk to other companies that are a little bit smaller, it seems like they're experimenting, but they don't have a clear purpose in mind. I think that if you just have a clear strategy, if you know what value you want to extract, and if you have the right people involved, value can be extracted relatively quickly. So sometimes it's better to hire expensive experts rather than junior people straight out of school. Because my experience talking to experts in the market and hiring many of them is that you tend to be more pragmatic the more experience you have. You're not going after shiny diamonds. Many companies fall into the trap of hiring data scientists which want to do neural network modeling. But that's not what most companies need. They need a regression model because it's twice as good as what they have in production today, which might be business rules and will generate a lot of value. If you reach that value, you will find funding for additional activities. So the complex usually comes in the end. The simple comes in the beginning. But many companies and many newly graduates, unfortunately, try to jump to the most complex solution early on. and companies are not there. So in my opinion, start easy. And I mean, I think there's even papers from Google stating that that you should start with the infrastructure, easy modeling, and then go into complex improvements and refinements.
Yeah, maybe I don't know if we have a few seconds. What, as researchers and educators, what should we focus in filling this gap in the need for expertise in the area? What should be taught, and also what kind of research would be practical to different companies?
I think, first of all, I think this, where you are right now discussing, is one of the most crucial areas to be discussed in research. I think we're lacking a lot of best practices in AI engineering in general.